Hey guys, my name is Eric Albers. I'm the product manager for the CycleOps brand here at Saris Cycling.
Hi, I'm Nate Dowse. I am the manufacturing engineer supporting CycleOps here at Saris Cycling.
Awesome. Today we're going to show you some inside information on how we manufacture the HAMR Smart Trainer. We're going to start with a process in the manufacturing that is the machining. We have a casting that we get from a supplier. It's an aluminum casting, really sturdy, strong, but that casting has some rough edges when it comes from the supplier, and we take that in-house and we do our in-house machining on that piece.
That is correct. First things first, we'll take it, we'll inspect it. If it passes our acceptance criteria, we'll clean it up, we'll shot blast it, file away any flash, and then load it into our HAAS VF4 for some machining.
Cool. So I guess without further ado, we're going to go ahead and get you started and showing you the process here. It's really it's a longer process, but it's really important to us that we have this process in-house because it allows us to pay really close attention to detail.
Yep.
Right? Yeah.
So it allows us to do minor corrections to anything in real time. So if we're having any trouble on the line, if customers have any complaints, we can immediately close that feedback loop and start talking to our machinists.
Right. And this machine is incredibly accurate, and our machine operators are very, very talented operators where they can, like I said, make adjustments on the fly if they need to. And the accuracy of this machine is within thousands of accuracy that we can get to on our machining. So why don't you tell us some of the first steps that we see happening here in the process?
So the first thing we're doing right now is we're probing the main bearing surface for your drive pulley. Everything's based off of that. So it allows us to keep our belt perfectly in line between the drive pulley and the resistance unit.
And that's really important. It helps reduce, obviously, vibration. It's very important on trainers because of the gear reduction you have in this trainer. That flywheel is moving incredibly, incredibly fast. So vibration translates to noise as well. So if we keep all those surfaces true, we eliminate a lot of hassle on kind of the end of line, what we consider, before it goes out to the customer.
Yep, it also helps increase belt life. If your belt's staying in one place, it's not walking around, you're not getting any extra wear.
Yeah, it's a really, really important part, actually a really, really good part you brought up because, belts, it's a wear item. They're going to wear over time. We've manufactured the hammer so that the belts can be replaced if necessary. Luckily, as we make this video, we've been manufacturing the hammer for a year and we haven't had to replace any belts in the field yet, which is pretty awesome.
Correct.
I mean, and a lot of that goes to this process that we're watching here and why it's so important to get everything perfect.
Yeah, so right now we're plunge cutting the axle bore. So we'll make a couple of passes here. The machine actually increases accuracy the more passes you take. You get a little bit of loading through the tool as it's cutting that circular diameter. And as we go through and we cut more and more material, it's going to load a little bit more. So we'll take a final pass and just barely kiss it around the sides to make sure that we have a very, very accurate bore for the axle.
Right. Awesome. Can you, we bought this, we actually invested in this machine for the hammer, which is really cool because, we wanted to bring some of these processes in-house, and we've done some machining in-house before, or a handful of machining, but we're doing a lot more with this product, and just watching this process is really fascinating to me. Can you, what's happening? I'm seeing lots of water spraying, I'm seeing things move around, like what is happening here?
So right now the water is actually a water and coolant mixture. It's non-corrosive. It helps cool the tool down. Cooling the tool down allows you to get cleaner surface finish as well as a longer tool life. It helps evacuate some of the chips. So as it passes, it's ripping little tiny chunks of metal off, and you can get those out of the way. You can make a cleaner cut. A cooler tool will cut better. It'll drill better, tap better. So that's what the coolant's doing. And right now, if you've noticed, we've been running the same tool for a while here. We use that one tool to do a lot of our face cuts, and with end mills, you're allowed to, you can cut in the X and Y and also in the Z. So you can do faces, and you can also plunge with them.
Right. Interesting. Yeah, it's a really cool process. As we see this kind of move on, tools change very rapidly. So we are, looks like, I'm guessing, drilling out the axle?
Actually, this is the undercut tool. So on the backside of the hammer where your non-drive side end cap sits, we're actually facing that right now. So you'll have very, very accurate spacing between your dropouts. Which is essential for bike fit. Right,
absolutely. Cool. More tool changes.
Yep.
Quite the process here. We got a little break in the process that we're going to kind of skip over here. I've got our machine operator, Jesse, who's going to come back online just in a moment and show us the next step here.
Yep.
All right, so we got Jesse, which is our primary machine operator for the hammer, coming over, and man, this guy's great. Like I said, he knows this tool inside and out.
Yep.
And, he's offered suggestions to pull time out of the machining process, but I think, like I said at the beginning, this is almost a 15-minute process per hammer, so obviously attention to detail. And what we got here? What's this?
So right now we're pressing in the axle.
Wonderful, yeah.
So we're pressing into that bore that we machined earlier.
So that was the last step. We've cleaned it out, and that's important for accuracy and the dropout spacing.
Yep.
And now we're pressing the axle in.
Yep. Doing it this way allows us to ensure that nothing changes. So the casting's in the fixture, it's not going to move. We machine everything to that, and then it allows us to press the axle right down the center of the bore that we had just previously drilled. So now we're going to go clean up the outside of that bearing face, which is going to stay perfectly concentric with that axle.
So we're making that bearing face concentric with the axle, and what's going to go there is the bearing and the large pulley.
Yep, your large drive pulley.
For the belt. Okay, cool. We talk a lot about the axle and how important it is for accuracy within the dropout spacing, but the hammer is a really unique product. You, like myself, you're mountain bikers.
Yep.
And how great is it to have this product come out of the box and be able to fit 142 through axle, 148 boost through axle. All the adapters are there. It's all set up. It's really, pretty awesome that that all happens.
It's great, especially if you're a cross rider like me and you have what's essentially a road bike, but it has 142 dropout spacing.
Right.
Fitting that on a regular trainer is not as easy, and this just fits right on, no problems.
Yeah, no adapters, no nothing really necessary. So, a lot of people that are watching this, I'm sure, have a lot of bikes just like us. So switching back and forth and being able to adapt to those bikes is really important when it comes to the trainer you want to ride, and the hammer, it'll do it all. So, cool. So we watched earlier, we're facing all of these spots in the trainer. So we're facing it. What goes onto these pieces? What goes onto those parts?
Okay, so when we face them, what we're doing is we're essentially making every screw boss coplanar. So we're making them all perfectly aligned with each other. And then what we're going to mount to them is our side cover, for one, mounts to all these screw bosses, the circuit board, and then also the resistance unit inside of there. And keeping that distance between the resistance unit and the circuit board is essential, because we have a temperature compensation sensor on that circuit board, and it needs to be close enough that it can make the adjustments necessary as you heat up the trainer to keep you accurate. But it can't be too close where you'll accidentally nick it if anything were to happen. So,
and that temperature sensor that Nate's mentioning is sensing the temperature of the actual flywheel. We have methods of determining the temperature of the board as well, but that sensor is the temperature of the flywheel. It's important to know as things heat up and cool during a training session. So. Cool. So we got the side cover we're facing for. We got the circuit board, and obviously the RU, which is really important because we talked about how important it was to get everything concentric for the large pulley. Now, if we're not exactly perpendicular with the RU, then again, we're going to have the same vibration or noise problems that come from that. So using the machine like this allows us to be just incredibly accurate in that process.
Correct.
So we've faced them, and I believe what it looks like is we're tapping them right now. We're actually tapping those holes.
So we'll drill and tap them. We have 10 1/4-inch screw holes and 6 3/16 screw holes. The bigger ones obviously are for the RU. You want to hold that thing rock steady inside of there. You can't afford to have that thing moving around at all.
Right. Wow, it's just cool watching this.
Oh, yeah, it's a hypnotizing process.
I know it is, isn't it? How many of these, so we talked about it, I mean, man, we said about 13, 15 minutes per process. So, I mean, there's a lot of love and a lot of attention that goes into each one.
Like I said before, we're shot blasting every single one of these. We're inspecting every single one. And we're doing a little bit of hand filing on each one to clean up some flash and some issues like that.
Right.
So, you know, it's not just the time in the machine. We're also putting 10 to 15 minutes of work outside of the machine to each casting.
So these are, you said they're shot blast, which is, correct me if I'm wrong, that's a process that happens before the machining. So right before they go into this machine, there's shot blast in the machine right next to it, the shot blast machine.
Yeah, we have this big old school giant shot blaster that we shoot a bunch of stainless steel, tiny BB shot at it.
Cool.
And it allows it cleans it up, it knocks 99% of the flash off.
Right. Adds a little bit of texture to it.
Yep, it helps make the paint adhere a little better as well too.
Yeah, sure, absolutely. Excellent. And what are we doing here? Are we still tapping?
Right now we're drilling, so that's where that pecking motion comes into play. It allows us to take some of the chips that are building up in the hole, get them out, and so we end up with a nice clean hole for the tap to come through.
Sure.
Yeah, you're mentioning Jesse and our machine team here. When we initially set this up, our machining process was closer to that 17, 18 minute mark. Yeah. And we gave these guys a green light to do whatever they could to speed it up while still maintaining quality. And they found ways to change the path that the machine's moving in-house, sped up some tool changes. They, instead of changing some tools, just keep the same tool in there. So they were able to reduce
the steps of the. Interesting.
Yeah, we were facing with a different tool than we were using to clean up the bearing surface. And they went through and just reduced some of those steps. And taking steps out takes time out and allows us to keep up better with the demand.
Yeah, absolutely. So we talked a little bit about what happens before this process with the shot blast, and after this, they get blown off. I think we're going to see here just momentarily. I believe it's done. Jesse's going to open and kind of clean it off, and then we really send it to paint and come back and assemble.
Yeah, so we'll do one more visual inspection to make sure nothing crazy happened during the machining, and then we'll package it up for paint.
Awesome. Great. Well, this has been really informative. You know, I've never seen this actual perspective of the machining process before. So it's kind of neat to be inside the machine here, seeing what's happening. You know, the attention to detail, the quality of the product, the durability of the product, really is what the hammer is all about. You know, I hope this was informative for those guys watching. It's great.
Yeah, excellent.
Cool. Well, thanks for joining me today. Again, thanks for watching. Feel free to check out the hammer. We've got a lot of dealers all over that have these in the shops. Check out our website to find out where you can try the hammer, where you can buy the hammer. Otherwise, thanks for watching.